Hello, this video for the final project of the CSE 535 mobile computing course is on the BraiNet project, also called the Thought ID project. The group members that worked on this project include myself, Niharika Datta, Chainika Saikia, Sarthak Khanna and Aditi Sonik. The objective of this project is to enhance mobile phone security by using the user's brain signal to log into the phone. This is a highly secure authentication method since it is virtually impossible to replicate a person's brain signals, which is why the name Thought ID is so apt. In the home screen of this application, we have an input text box that takes in the user's name and maps a brain signal to this user. We collected the sample data of brain signals to use for this project from the Impact Lab, and we randomly assign a particular brain signal to a user since we do not have a headgear of sensors to collect this data from the user in real time. This dataset is then split into train and test data, the former being used as a signature while the user registers for the first time, and the latter is used to test the authenticity of the user while trying to unlock the phone. While registering, the brain signals of the user are stored in both the cloud server and the fog server. The cloud server is a server in a different network from the network to which the mobile phone running the application is connected to and has significant computational resources, due to which it is very time efficient while running backend operations. Whereas the fog server is in the same network as the mobile phone and hence amounts to less network delay but is not as computationally powerful as the cloud server. The application decides which server to use using an offloading algorithm that we developed that sends a dummy packet to both the servers and then computes the network delay and the battery consumption observed from each server, and using these parameters decides which server is best to use in a particular scenario. For example, if the phone battery is less than 25%, a threshold that we selected, then the algorithm chooses the server that resulted in consuming less power to save on battery. These servers are implemented using PHP servers, and there are two APIs which are called by the Android application. The first is the Upload to Server API, which uploads the brain signal file to the fog and the cloud server. The second Check Signature API is used to check if the current user's brain signal matches with his registered data. Now let us see a demo of registering a new user in this BraiNet application. We can see that the user has been successfully registered, which means that his brain signal has been stored at both the servers. Now in these servers, for matching the current brain signal or the test data of the user, we have trained an SVM or a support vector machine model of the user's training or registered data, which is then tested against the test data or the signal sent to the user when the user is trying to unlock the phone. The comparator algorithm that is implemented at the backend servers predicts the user of the current test brain signal using the SVM model, and if it is a match, returns a successful message to the application, which then allows the user to log in. This is conveyed through the welcome text view, as will be seen shortly in this video. This might take a few seconds as the SVM model was trained on a pretty large dataset of the user's brain signals. There, as we can see, this means that the user was authenticated and logged in. Now we will also demonstrate a few negative test cases in this video. For example, if an unregistered user tries to unlock the phone, since their brain signal data does not already exist on the servers, the application does not allow the user to log in and shows an appropriate error message, as you can see. In another scenario, if a user is already registered and tries to register again, the application does not allow that and an appropriate error message is displayed, as can be seen. Also, if the user's brain signal collected at the time of unlocking does not match with the registered signal using our trained SVM model, the user is not logged in, which is demonstrated with an unauthorized user message. This application has been successfully tested using multiple user data, in both the fog and the cloud server and was observed to give a high accuracy while testing with the trained model. Thank you for watching.